So we've seen how the radical product rule works really nice for simplifying radicals. It takes a number and we can break it into two square roots, part that we can square root, part that we can't, and we can simplify it. Now let's see how this works with variables. Okay, so remember that variables just represent numbers. So everything that we just did with those numbers also works here. Now one other thing that we should notice here is that when we take the fifth root of 2 to the fifth, well, that power gets divided. It's a 5 divided by 5 becomes 2 to the first. Y to the fifth becomes y to the first. We don't usually put the first here, but that's the idea. It's y to the first, all right? So keep that in mind. That division is going to be important. All right, so what's going on here? Well, we want to break this up in the same kind of way. We're going to break it up into things we can square root and things we can't. And then looking ahead, our goal is going to be to take this and break it up into something squared. All right, and then the stuff that we can't deal with, we'll just leave under the square roots. All right, so when we have 5x's, or x to the fifth, well, if we write this as, if we break this up into x to the fourth and x to the first, then this number can be written as x squared squared. Okay, x squared squared is x to the fourth. So we can simplify an even number of x's, x to the fourth, an even power. All right, because that can be written as x squared squared. And what about y to the sixth? Can we simplify y to the sixth? I think we can, because y to the sixth can be written as y to the third squared. Remember when we have power to a power to a power multiplies. So y cubed to the second power is y to the sixth. These are the same thing. Okay? So we can simplify y to the sixth. We can simplify x to the fourth. Now, I have to have 5 x's in my whole expression here, so I'm going to have 1 x left over in the cannot be simplified. So I like to think of this as, this is the things we can simplify, these are the things we cannot. Okay? Just like we did with the numbers a little bit ago. So, all right, we've broken up the y's, we've broken up the x's. Now let's break up the z's. Okay? So the z's, well, we want to figure out how many z's we can simplify so that we have 13. We have 13 z's all multiplied together. Well, we can simplify z squared. We can actually simplify up the most we can simplify is z to the 12th. So I'm going to break this up as z to the 12th, and then I got to have one more z here because z to the 12th times z to the first is z to the 13th. Okay, why do we pick 12? Well, one, because it's close as we can get to 13. That's an even number. All right, and so I can write that as z to the 6th squared. 6 times 2 is 12. Okay, and I've got this leftover z to the first I've got to leave in here. All right, so what's happening here? First of all, we're breaking this up into things we can simplify and things we can't. The things we can here, all these exponents are divisible by 2. 2 is the invisible index here, right? Because it's a square root. And this is a step that we'll probably skip this step eventually here once you really get it down. But the idea is we can write this as x squared squared, which is x to the fourth. Y to the third squared, which is y to the sixth. Z to the 6th squared, which is z to the 12th. Okay? And in the end, these cancel. So this square cancels with that. Okay? And so we have x squared, y cubed, z to the 6th times the square root of x, z. Okay? So basically we took out every pair. And another way we could do this, we could write this all out. And if you watch other videos, you'll see this written out: X, 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 Y, 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 Y. You'll see we'll write them all out. And it's a whole bunch of extra writing that we don't need, okay? Every pair of X's is going to be simplified because we can break it up into these terms squared, or these factors squared. All right? And so that's the idea. Now let's try one more. What about cube rooting? All right, well, when we're cube rooting, so we want to break this into things we can cube root and things we can't. All right? So first we look at the number. Can we cube root 54? Well, no, we can't. Now, the simplest way to do this is to think about your perfect cubes. Our cubes are 1 times 1 times 1. 1 to the third power is 1. 2 to the third power is 8. 2 times 2 times 2. 3 times 3 times 3 is 27. And 4 to the third power is 64. And that's enough. Do any of these multiply into 54? Does 8 go into 54? No, it does not. Does 27? I think it does. 27 times 2 is 54. So we can cube root 27. That's something we can cube root, but we can't cube root 2. 27 times 2 is 54. Can we take the cube root of x to the third? We sure can. Cube root of x to the third is just x, and we'll do that in a second. So we only have 3 x's here. We don't need any in the leftovers because all of our x's are in the can cube root. Okay, what about the y to the 8th? Well, 8 is not divisible by 3, so we cannot cube root that. Okay, so what's the closest multiple of 3 that we can get that's close to 8? Well, that is y to the 6th. But we need to have, we have 8 y's, y to the 8th, and so we need 2 of them over here. All of this has to be equal to this. We have to have all the ingredients. We're just splitting the ingredients up here, all right? And then we have z to the 22. Is 22 divisible by 3? Nope. The closest we can get is 21. So we have z to the 21. But we need to have 22 z's, so I need to have 1 extra z over there. 21 plus 1 is 22. All right. So what does that do for us? Well, we have our leftovers here that we can't deal with. 2y squared z to the first. Let's try that a little better. There it is. Okay. And then we can, this we can write as the cube root. And we want to write this out. I'm going to go ahead and write this out as something cubed. So we want to think 27 is 3 cubed. X to the third is x cubed. All right, so notice this little cubed. It's kind of hard to read over there. Let me make it a little nicer. Okay, we've got cubed. Okay, so under this radical, we have x cubed, 3 cubed. What do you have to cube to get y to the 6? Well, it's y squared, because 2 times 3 is 6. Power to a power gives us 6. What do we have to cube to get 21? Well, we have to cube, we got z to the 7th. 7 times 3 is 21. Okay? All right, and so all of these cancel. All that we're doing, all that's going on is we're dividing each of these by 3. Okay, so we're pulling out as many, the biggest multiple of 3 we can. Those all getting divided by 3. We got a 1, 2, and a 7. And that leaves us with our final answer of the cube root, nope, sorry, I just did the cube root of 3 x to the first, y to the second, z to the 7th, times the cube root of the extras, 2y squared z to the first. You don't have to put the first on the z. All right, so that's the idea. Okay, notice all that really happened was we took as many 3's out as we could, x to the third, and it got cube rooted, became an x. We took as many 3's out of here, Okay, there's 6. 2 times 3, there's 2 3s, and the remainder is 2. There's 7 3s and 22, and we're left over with 1. Okay, so this is the ones we can't simplify, and this is. Okay, now I got to back up. We forgot one little thing here. Notice in the instructions, okay, we've got to use absolute value signs. In other words, we've got to ask ourselves, can these be negative? Is it okay for cube root to be a negative number? Yes, it is. Odd roots can be negative. We do not need absolute values there. But let's back up here. This has to be positive. So we have to ask ourselves, can these be negative? Yes, this one can. Okay, x squared, no matter what number x is, this will be positive because an even power will be positive. But y to the third power, this could be negative because the third power, if you put a negative number in there, that could be negative. So we should have a negative, we should have absolute values there to keep that positive. Okay, you might write this like this: x squared z to the 6th, absolute value of y cubed, and then the square root of xz. So the idea is anything that comes out, we've got to make sure that that's positive if we took the square root, because this is an even root. Okay, and a little reminder, even roots that lead to odd powers need absolute value. Okay, even roots, this is a square root. This is an even number. 3 is not an even number, but 2, that is an even number. Okay, even roots that lead to an odd power need absolute values. Okay, don't get too hung up on that. It's important. It's not too major. Okay, the idea is we just need to make sure this is positive. All right. So that's simplifying with the radical product rule. Next, we're going to move on to the dividing radical expressions.